In this video, we're going to be proving the derivative for the inverse of secant of x, which is equal to 1 over x times the square root of x squared minus 1. For starters, we are going to let the inverse of secant x to be equal to y. Therefore, by definition, secant of y will be equal to x. And we know the definition for the secant function within a right triangle to be equal to the inverse of the definition for the cosine function, which is equal to the hypotenuse side of the right triangle divided by the adjacent side of the right triangle relative to angle theta. Therefore, if I construct a right triangle as such, and I assume one of the angles to be y, that means the hypotenuse will be x, the side adjacent to y will be 1, and the side opposite to angle y will be the square root of x squared minus 1. And this comes straight off the Pythagorean theorem, which says that a squared plus b squared is equal to c squared, where a and b are the two legs of the right triangle and c being the hypotenuse. And to find any leg of the right triangle, such as a, will be equal to the square root of the hypotenuse squared minus the other leg of the right triangle squared, hence obtaining this opposite side relative to angle y to be the square root of x squared minus 1. And what we can now do is take the derivative on both sides of the equation secant y is equal to x to obtain secant y times tangent y times y prime will be equal to 1. To rearrange this, we get y prime is equal to 1 over secant of y times tangent of y, which is also equal to the derivative for the inverse of secant x. And the reason why for this is because we previously assumed the inverse of secant x to be equal to y. Therefore, if we take the derivative on both sides, the inverse of secant x's derivative will be equal to y prime, hence making this equation true. And now we can do is we can break up the fraction to be equal to 1 over secant of y times 1 over tangent of y, which is then equal to cosine of y times cotangent of y. And we know the definition for the cosine function within the right triangle to be equal to the adjacent side relative to the angle theta divided by the hypotenuse of the right triangle, whereas the cotangent function is the inverse of the definition for the tangent function, which is the, let's see, that would be the adjacent side over the opposite side relative to angle theta. Hence, if we apply for cosine of y times cotangent of y, this becomes 1 over x times 1 over the square root of x squared minus 1, which will then give us a grand total of 1 over x times the square root of x squared minus 1. Hence, proving the derivative for the inverse of secant function to be equal to 1 over x times the square root of x squared minus 1.